Welcome to Reasonable Data Science, the channel devoted to teaching a reasonable amount of data science in a reasonable amount of time. This video is part 3 of my series on how to use Jupyter Lite for data science. It will show how to conduct exploratory data analysis, which is one of the most important tasks to complete before any model or algorithm can be created. We will continue to use the same Titanic dataset we imported into our Jupyter environment in part 1 and part 2 of the series. The link to the dataset is in the description below if you need to download it. Before conducting any exploratory data analysis, we need to import the proper packages. For what we'll be performing in this video, we need to import the pandas package, which we looked at in video 1 and 2, the numpy package, which we also looked at in video 1 and 2, and then a new package, which is matplotlib.pyplot. And this package here, the matplotlib, will allow us to create visual charts such as bar charts, histograms, and scatter plots. So just remember, when you run this, you might get a deprecation warning for pandas. Just ignore that for now. I've also gone and overridden the default setting in Jupyter here, so I want it to output 1,000 rows in any table and output all of the columns. And then I've also imported the data set as well and set it equal to our standardized df variable. Before I jump into the code, what I'm going to do is I'm going to get rid of this left-hand pane so it's a bit easier for you to see the code, especially when we start looking at charts. That way it takes up the whole screen. So I'm just going to go to the View menu, Appearance, and then Show Left Side Bar and uncheck that. So the first item that I always check in the data set is how much data is missing. So you can check the missing data by using the code df.isNA, open and close parenthesis, and then .sum. And then when you execute that, what that does is it outputs all of the columns in the data set and then how many rows are missing. And so, for example, age has 177 missing values in that column. What does a missing value look like again? Well, if we were to look at df of age and just look at that here, a missing value is anything that shows NaN. And so there are 177 rows in this age column that show as NaN. If we were to look at df of age and then do .count, which we learned last week or last video, you'll notice that there are 714 rows. But when we look at our data set entirely using the df.shape, there's 891 rows. So why does age only have 714 and our entire data set is 891? Well, that's because 177 of the rows in age are missing. So if you were to take 891 minus 177, we then get 714 rows. So in video 4 of this series, I'm going to dive in and show all the ways to handle this missing data in this data set. But for now, all I wanted to just point out is how to identify that the data set has missing data. So tune back into video 4 and we'll show how to solve all this missing data. So step 2, kind of in exploratory data analysis, is to begin summarizing the data. A great way to start summarizing data is by using the function .describe. And so if we say df.describe, what this will output then is a table with all of the columns that Python thinks are numeric values, and then all the summary statistics. And so for here, you can see that age has a count of 714 and an average age of 29. But one thing to be aware of when you use the describe function here is that Python will output any variable it thinks is a numeric value. And so passenger ID, it's a numeric value in the data, but it's not something we can really calculate any sort of summary statistics on. The same thing with survived. It's a numeric value, a 1 and 0, but it's a binary variable. You either died or survived. So you can't really calculate the average of survived because you either died or you survived. And so that's where, when you're using the describe function, you need to be really careful. So instead, what we can do is we can reference the columns that we know are legitimate numerical columns, such as age and fair, and just run the describe function on that. So we're just going to say df of age and fair, and then dot describe, and just run the describe function on those two columns, and then we know it's legitimate that way. If you don't like the describe function, we can also run each of these summary statistics by using their individual function itself. So if we wanted to just look at what is the mean of these two columns, we could just say dot mean on the back of them, and that would give us the same mean that we see up here in the describe table. If we wanted to look at what's the max, we would just say dot max, and that would give us the same max up here, 80 and 80, 512 and 512. So it's up to you as the user. If you want to use describe, that's my personal preference because it outputs everything in one nice table, or you can look at it individually with the individual functions. Another way to summarize data is to calculate frequencies, which is just a fancy word for saying counting the data. So the great thing about frequencies, though, is that you can look at non-numeric data and start to summarize that type of data. And so let's say we wanted to count the number of passengers that survived or died in the data set. We can use the function value underscore counts. And so we're going to say df and then survived dot value underscore counts. Then inside this function, we can specify two items. We're going to say drop NA equals false. So that way, if there's any NA values, it'll actually get returned as its own category in our output table that we're going to create. And then normalize equals false. So what that does is that returns relative frequencies, which we're going to look at that next. So when we run this, what this does is it returns all of the, it counts all of the rows that have a 0, or all the rows of the passengers that died. So there's 549. And it counts all of the rows where the passengers survived of a 1. So it just creates a really nice summary table of all the values that are in our survived column here. And if you notice, if you were to take 549 plus 342, that adds up exactly to our 891 rows that we got when we run df.shape, and we run that. Looking at counts is great, but personally, I like to look at what's called relative frequencies, which is taking a percentage. So it's 549 divided by 891. Using relative frequencies standardizes the data, so that way it's a little bit easier to compare to other types of data. And so to change it from a frequency to a relative frequency, we just go down here and change our normalize input to true. So we're going to say true. And you can see when we output that, it gets 61% of the records died, 38 lived. That's the same as if we were to say 549 up here in our frequency table. So if we were to say 549 divided by 891, that's the same thing. We'd get 61% there. So value counts, this function here, a really, really great way to begin analyzing non-numeric variables. Let's just look at one other example here. So if we were to say, instead of look at the survived value, we wanted to look at P class, which there are first, second, and third class in our data set, and we output that, it looks like 55% of our data is in third class, 24% is in first class, and 20% is in second class. And so what this value counts does is it will give you a category for every unique value in the column that you're looking to summarize here. So it's a very powerful function and a very great way to start summarizing data. Now let's say we wanted to count how many passengers survived or died by each class. Well, we can use what's called the group by function, which will group the data by survived, by class, and then count how many survived within each class. And so we're going to say df.groupBy. And then first we're going to group it by the survived column. And then we're going to group it by p-class column. And then I'm going to say drop NA equals false within this as well. Just in case there's any NA values, I like to just see those in the output. And so we're going to group it first by survived. We're going to group it next by p-class. And then on the outside of our group by function, we put a bracket, and this is the variable we're going to count, or we're going to summarize the data by. So I'm going to say p-class and then .count. So again, we're grouping the data by survived, then by p-class, and then we're counting the number of records using the p-class column. And so when we run that, it outputs a really nice table that is first grouped by survived 0, 1, by p-class, and then the number of records within each of those. So when we look at the passengers that died here, you can see that third class had 372 deaths, which is way more than second class and first class on here. So our data is showing what history has taught us, where on the Titanic, if you were first class, you were more important, so you probably got on a lifeboat sooner. If you were third class, you were less important, and you probably didn't get on a lifeboat. That's just how it was back in the days of the Titanic, as history has taught us. But now let's check another theory of history. So another theory in history is that women and children survived more than men did on the Titanic, because back then it was common practice for men to give up their seats for women and children. And so what we can do is we can just copy this group by function, and we'll add a third grouping variable in here. And so when we run that, it groups it by survived, p-class, and then by male and female. And the only categories in this data set are male and female. And so what you'll notice is that when we look at third class here, well, passengers that died, and then we look at third class, males, 300 of the 372 third class passengers that died were male. So again, our data set is going right with history and showing that males, specifically males in third class, had a higher rate of death on the Titanic. So using this group by function is a very powerful way to start to really understand your data. But let's say we wanted to add in a numerical variable to calculate on. So instead of counting by p-class, let's say we wanted to find the average age for survived p-class and gender. Well, what we can do is we can just copy our group by function again. And the variable that we're going to use to summarize now is going to be age. And we're then going to instead say count, we're going to say mean. We're going to run this one here. And so again, passengers that died, and then by p-class, and then by male and female, it's giving their average age. And so when we look at the males in third class who died, had the highest rate of death on the Titanic, their average age was 27 years old. We could also switch this if we wanted to the median and just rerun that if we want to look at the median age instead of the mean age. So again, this group by function is very flexible on how we do it. So using value counts, using the group by function, two great functions to summarize your data into nice summary tables here. But let's say instead we wanted to look at some summary statistics in a bar chart format. Because at the end of the day, bar charts or charts in general are a little bit easier for the audience to read. And as the saying goes, pictures are worth 1,000 words. So we can just use what we learned here and put this into a bar chart. So if we wanted to just create a quick bar chart on the number of passengers that survived the Titanic, we can just say df.survived, use our value counts function, and then I'm going to say normalize equals false. drop NA equals false. And then something new, so if we were to run this, we get the same output that we got before. But what we want to do is we want to change this from a table to a bar chart format. So all we need to do is then add a dot plot on the back end of it here. And within the plot function, we're going to say kind equals bar for a bar chart. And just to get fancy, we're going to say color equals blue. So that way we can specify the colors of this chart. And then if we would come down here, we can just say plt.show, which will then show the chart here. And so when we look at it, we can see that there's a column or a bar for 0, which for that's died. There's a column for 1, which means survived. So, and then the axis up here shows that there are 549 that died and about 300 and some that lived. This chart is kind of ugly. There's no title or axis labels or anything. So we can add those in here. So if we were to put our cursor in here and shove down the plt.show, we can then quickly add in some titles and stuff to make it a bit nicer looking of a chart. So we'll just say plt.title, and we'll just say like survived frequency. And then I want to add a Y label right here, which will say frequency, plt.y label, frequency. And then we're at an X label here, and we're say survived equals 1. That way the user knows how to read this chart. So we'll say plt.x label, and we'll say survived equals 1. So if we were to just, and then one thing I don't like is that the axis labels are rotated. So then we're just going to say plt.xticks, and then rotation equals 0. And when we run that here, you then have a nice title up here on the chart. We have a Y label, we have an X label, and those labels are now turned so we can more easily see them. We can also create, instead of a vertical bar chart, we can create a horizontal bar chart. So I'm just going to copy this one here, paste it down here. And the only thing that we need to do to change it, well, one of the things we need to do to change it from a vertical to a horizontal bar chart is we say bar H here. And so if we were to run that, it now flips the bar chart to a horizontal bar chart. But when you look at it, our X and Y labels have also flipped. So we need to go in and change these. So we need to go in and say survived equals 1 on the Y label now. And on the X label, we're going to say frequency. And just rerun this one so it's a bit nicer of a chart. So that's how to create a bar chart with one variable in it. So this is just looking at the count of survived. We could put any variable in here. We could say count of P class if we wanted to, and that would do the same exact thing. It would just give us a 1, 2, and 3. We'd have to change our labels here, but any variable you put in there that's non-numeric, it'll give you a category for all of that. But let's say we wanted to create a bar chart that shows the average age of passengers that survived or died. So now we're going to be grouping two variables together. We're going to be grouping the survived. We're going to be grouping the data by survived and then calculating the average age for survived or died. So here's where we can use our group by function. So we're going to say df.group by, and then within there we're going to say survived. And then the variable we're going to use to calculate the average is the age dot mean. And then it's the same thing. We just add the dot plot function on the back end of it. Say kind equals bar. And then this time I'm going to say color equals red. Say color equals in parentheses red and green. So now we're going to have two different colored bars on our chart. And then we can just say plt.show. We're not going to add any labels or anything for right now. And what this shows is a red bar for the passengers that died, a green bar for the passengers that survived, and then their average age. So it looks like 30 was the average age of the passengers that died, and about like 28 was the average age of the passengers that lived. All right, if we wanted to look at what was the average age of the passengers by P-class, by survived and by P-class, we could also do that as well. So all we'd have to do is come in here and just add in another variable to our list here. And then one thing we will have to do is we have to add in, before we use the plot function, we have to add in the function unstack. Otherwise, the data won't plot properly. And so if we were to, then we can just get rid of this color. We'll just have it all as the same color. And let's just run this and see what this outputs here. So we let Python choose our colors for us. So what this shows is then it's grouped by people who died, people who survived. It's grouped by then a bar for each P class up here, 1, 2, and 3, color coded. And then it's finding the average age for those P classes. So it looks like first class, people who died, had about an average age of like 42, 43. P class, first class passengers who survived had an average age of about 35. Third class passengers who had the most death, their average age was about 28, I think, while the ones that survived, their average age was about 22. And so using this group by, and then the unstack, and then the plot, a great way to visualize the data. If we wanted to instead look at what was the count of P class that survived and died here, we could just do the same thing. We could just copy this, change this to P class. We're going to change this to count. We're going to leave bar the same. And then if we wanted to add colors, we could just say color equals, we could say blue, orange, and then gray. And then that would, and then we'll close the parenthesis again. That will output a chart that has blue, orange, and gray colors, and it's counting the number of passengers that died by P class. So as we've looked at before, third class had the most passengers that died, and so that bar here is way taller than all the other bars combined. We can then add a third group here if we wanted to. If we wanted to look at what was it by survived, P class, and gender, and we wanted to count it by gender instead. So we're going to change this from gender here. We can then do that as well and group that. So this one starts to get a little crazy, but basically it's looking at 0, 1, so survived and died, whether you're male or female, color coded, and then the number of counts. So if you see here, the died, 0, this is the category for died, and then third class, you can see the males in third class had a way higher rate of death than the females in third class, and males in third class had a way higher rate of death compared to everyone on the ship here. All right, so that's just a really easy way to start visually plotting your data using the group by and the value counts functions. Again, you could look at it through a table or you could look at it through a bar chart. Either way works. They give you the same outputs. If you wanted to start doing some univariate analysis instead, where you're looking at and analyzing one variable, you can use what's called a histogram. So if we wanted to look at what was the distribution of ages in our data set, we could just use plt.hist. And then within that, we're going to say df of age. And then I'm going to say bins equal auto. So that way Python's just going to calculate that for us, the bin size. And I'm just say plt.show for now. And that shows a histogram of the distribution of our age column here. That's a little bit ugly, so what I like to do is I like to say edge color equals black on here, just to give it some definition. And so when we run that, you see it now puts a line around the different bins in our chart here, which helps the reader see the different bin sizes. So it definitely looks like age in our data set is skewed to the right or skewed positive. It has that long right tail here. So if we wanted to instead choose our own bin size, we can just copy this. I'm going to paste it down here. And where it says bins here, we can just specify the bins that we want to use. So if we wanted to say 0, 10, 20, 30, 40, 50, 60, 70, 80, we could then add those bins in here. And when we run our histogram, it'll have those exact bins. So we're now creating a histogram even with bins that are 10 years in age perfectly apart here. So it makes it a little bit nicer of a histogram. You can just see it a little bit easier than you could when we let Python choose our bin size here. And you can get really fancy with these. Again, if you wanted to add in titles, you could just say plt.title, and you could say like histogram, and then run that, and that'll add a nice title to there. You could add in those Y and X labels as well. So histogram is a great way to really visualize one variable and the distribution, but just remember that variable has to be a numeric variable in order for histogram to work. The last chart I want to go over is a scatter plot chart. So this Titanic dataset isn't really great for building scatter plots because it's a classification dataset where the target variable or the response variable is a binary classification. However, what we can do is we can look at the two numeric values in the dataset, which is age and fair, and create a scatter plot on those. It's not going to turn out great, but I just want to show you how to use the code. So what we can do is we can just say x equals df of age, y equals df of fair, and then we're just going to say plt.scatter, x, which is what we're defining up here, which is the age, y, which is we're defining up here, which is the fair, and then we're just going to say plt.show. When we run that, it'll output a scatter plot for us, where the x is the x axis, or the horizontal axis is our age, the vertical axis is the fair. Like I said, this data set doesn't really work great for scatter plots, but that's just a way you can use or build a quick scatter plot here using the matplotlib package. Well, that was a reasonable demo on how to conduct exploratory data analysis within our Jupyter Notebook. If you enjoyed this video, please like and subscribe, and then go to video 4 in the series, which will show how to handle missing data, how to process data into something usable, and how to conduct feature engineering. Thank you for watching.